point from Mike. Who is implementing the new protocol? Support will be in the next Bitcoin QT release, which they say on the blog post that we read previously, it'll be ready when it's ready. So we don't know exactly when that is. And is being worked on for Multibit/Android Bitcoin Wallet, Coinbase, and CoinPunk. BitPay is also committed to implementing it, so all merchants who use their services will get support automatically. If you're planning to support it, let me know and I'll add you here. So they've already got some pretty big names on board with this new protocol. What other features does this add? In version 1 of the protocol, refunds. The senders can submit some refund address to the recipient at the same time as submitting the transactions. Now, if the seller wants to give the buyer a quick refund, they can do so. No more problems with trying to guess the user's address and sometimes getting it wrong due to shared wallets. Bitcoin QT generates a refund address for every payment done this way, but you'll only see them if you actually do get a refund. Memos. Clickable links can already contain short strings or labels, but their length is tightly limited by what browsers will accept and what fits in a QR code. BIP70 allows payment requests to contain arbitrarily long memos, which can be used to describe what you are buying. This is super useful when the payment request is authenticated. And authentication is the next segment, but refunds, that's huge. What they've done, it seems like to me, is built in a feature that allows for a way to give refunds, but preserves, of course, the one-way nature of Bitcoin transactions.
Yeah, exactly. It's not reversible. It's just giving the merchant what is the correct address to send a refund if such a thing should arise. I can tell you, as a merchant in some of the products I sell, I have occasionally had to give refunds, and it's always a manual process. I have to contact the person who made the purchase. If I have the contact details, of course, ask them for a Bitcoin address, send the payment, and then hope that works. This will allow you to pre-arrange the possibility of a refund. And it really shows how you can make this transaction much more tightly coupled. So there's information flowing from the merchant to the customer, but also from the customer back to the merchant if they wish to do so. And behind the scenes, the nice thing is that this can use as many addresses as you want, which means a new address for every transaction without any of the complexity of trying to figure out which address you used.
That sounds great. Now, memos. Would those memos be public, like in the blockchain, or are they just kind of for your own information saying, well, I bought a Safe Paper Wallet kit from Andreas on...
Yeah, this is entirely outside of the blockchain. This is metadata that's transacted during the payment protocol. So it's basically information sent to your client, which will presumably be displayed on the screen, perhaps as a web page, telling you what this payment request is. And it can be much more verbose. So for example, you could have a receipt that has a product name that has a picture of the product and a price and the tax you paid and all of the other information in that memo. And that will show up on your screen, so you know you're paying the right person for the right product.
But it doesn't necessarily have to be incriminating, perhaps, because it's not public. It's just for your...
This is sent to your client. It could be discarded right after. It's not communicated publicly at all. The nice thing is that this actually continues to preserve privacy and anonymity in terms of not revealing extra information, but at the same time, it allows the clients to fully implement automated recycling of addresses to ensure that they never reuse an address. And that leads to much stronger anonymity. Now, think of it another way. One of the things you could do in a payment request like this is request that the payment be sent to a CoinJoin mixer or shared mixing address. So you could effectively use this to piggyback anonymization and remixing service on every transaction that goes through a specific merchant by default. That's pretty cool.
Yeah, that is pretty cool. What is authentication about? Mike said in the last point about memos that memos are really useful when the payment request is authenticated. So what is authentication? Bitcoin is a difficult project partly because we're moving money around with general purpose computers that can be hacked or get viruses. Visa and MasterCard have moved everyone outside the USA to special purpose hardware like chip cards and dedicated readers which can't have random apps installed on them. Our approach has to be a bit different, but dedicated hardware is still coming. The Trezor device is a mini computer just for Bitcoin that plugs into a real computer via USB. It has a display and a couple of buttons. It holds your private keys. When you want to make a payment, the details of the payment are shown on the screen, and if they're what you want, you press OK and things get signed. There's an obvious flaw with that design when combined with Bitcoin as it is today. The details of the payment you'll see on the screen will look like this. Pay 0.5 Bitcoin to 1 EasyEQ FB blah blah blah. Where did that address come from? Well, it came from your computer, the thing that probably has a virus on it. That virus could have swapped out the address sent by the online shop you're using for one owned by the virus author, and because they're just random numbers, you'd never know. Although the virus can't empty your wallet immediately, it can still steal payments when you make one, and avoiding that is the whole point of using special hardware. The payment protocol allows recipients to sign their requests under an identity. An identity, and identity is in quotes here, is just some arbitrary string that was itself signed by some, quote, certificate authority. The authority then signed statements that say, simplifying a bit, I, Bob Smith, believe address 1EZE ... is owned by Mike Hearn. Now, if your Trezor happens to trust that Bob Smith validates identities reliably, it can display pay 0.5 Bitcoins to Mike Hearn instead of pay 0.5 Bitcoins to this address. And that message can't be tampered with by any virus. As you can see, this is much safer.
The bottom line here is that in this decision, the Bitcoin developers decided to use existing technologies for doing basic identification and certificates. And the technology they're using is SSL certificates, the same stuff we use on the web, X509 certificates they're called, but that's the underlying certificates that are used for SSL. So when you go to eBay.com and you see a little padlock up there, that guarantees that you are, in fact, looking at eBay.com. Without that, someone could basically hijack your session, take you to a site that looks like eBay.com, but isn't. And then when you put your payment information in there, it's stolen. It's a honeypot. In fact, every Bitcoin address can be a honeypot. You don't know anything about it. It's just a random string of gibberish. This will allow you to associate that random string of gibberish to a specific signed certificate and then build some trust around that. So when you go to pay a merchant, you know that the money's going there. And this really makes it much harder to run man-in-the-middle attacks where you substitute a Bitcoin address with another. This is a big problem. Let's say you have a blog at the moment and you want to get someone to tip you. You put an address in that blog, a hacker can come along, hack into your website, edit that page, change the address. How long would it take you to notice that you're not getting any tips anymore? Your tips are mysteriously disappearing into the ether. So it's exactly that kind of scenario that you can solve. In this case, instead of having just an address and text, you would have it assigned as part of the payment protocol. You get a certificate against it. So it can't be substituted without breaking the certificate.
That does sound like it makes things more secure. So how do identities work? Who is actually saying, okay, this is Andreas Antonopoulos? He's saying, essentially, this isn't like a government issued ID or anything like that, or you have to show your passport and tie it to all your Bitcoin addresses or anything like that. What this is essentially anyone can get a certificate attesting to some kind of identity. Often it's just an email address or website domain name. For example, bitcointalk.org has a certificate containing its domain name. It can also be a legal name like Michael C. Hearn or Mt. Gox Limited. In fact, if you have a passport with a chip in it, then you already have a certificate containing your passport data, but it's not very useful because there's no private key attached to it. Sometimes certificates are paid for and other times they are free. The certificate authorities never get your private key. Instead, you generate a private key locally, then ask the certificate authority to sign your public key. At the same time, you prove your identity. If your identity is an email address, then you typically receive a clickable link there, for instance. If it's your name, you might have to submit some paperwork. But if it's your forum name or something like that, you probably don't. Basically, what he goes on to say is there's probably going to be a marketplace of certificate authorities that evolve, and they're going to be offering different levels, some free, some paid for, of certificates that are attached to different sort of facets or aspects of your identity. So this is not something that makes Bitcoin less private or less anonymous. It doesn't have to be your legal name, your legal identity at all. It can totally be something like a forum handle or an email address.
And keep in mind, this is for the merchants and the merchants who choose to attach an identity to their payment addresses. This isn't for the end users. You don't need to have a certificate as a buyer or as a client or as an end user, because you don't need to prove to anyone who you are when you're sending money. You only need to generate trust when you're receiving money. So this really affects merchants. And I think the smart move here was to piggyback on top of the X509 SSL certificate structure, because right now, if I want to get a domain or an email address certified, I can choose from 30 different certificate authorities, from VeriSign to Network Solutions to some of the smaller and cheaper ones, and they can produce a certificate that's widely trusted. They have the infrastructure for doing the verification, and it's relatively robust and has been already used as the foundation for SSL. So it's a really smart move because it leverages existing technology nicely.
So then he goes into talking about why can't we use the PGP Web of Trust, which is basically, I don't really understand it that well, but PGP is a way of encrypting emails and communications and other things. And the Web of Trust is when people validate and sign each other's keys, that certain keys belong to certain people. There used to be, or maybe still are, some things called key signing parties where people will meet in person and say, oh yeah, this person is who they say they are. I can verify that their key actually belongs to them, and I'm going to sign their key. And then it creates this web of trust, which is a bunch of people who have confirmed that they all are who they say they are. And you can kind of tap into that web of trust to verify people's ID. It's kind of technical and a little bit on the longer side, so maybe we won't go into that. But Mike is saying that it's really not possible to combine the PGP Web of Trust, nor would they want to, with the new Bitcoin protocol.
I think that this also gets into the question about should the perfect be the enemy of the good? Because that's essentially the other argument that Mike is making here, is that, yes, there are some problems with the existing SSL certificate authority system, notably that sometimes certificates get issued to people who shouldn't have them, and that sort of taints the whole thing. And so he lays out a couple of improvements that could be applied to the system as it is now. But really, that's the primary thing, is that this is an incremental step towards something better than where we are now. Is that right?
Even if SSL has had some flaws, it's got broken, there's issues with the certificates, it is by far the most successful broad-based deployment of encryption the world has ever seen, and probably the most effective security and privacy tool that we have ever deployed. I think the primary reason is really simple. As a user, you don't make a choice to use SSL. It just happens. And that's a key element of security and why SSL has been so successful. The burden is shifted to the merchants who have the funds and the motivation to do it, and the users get it automatically without asking. That's a really good security model. And, you know, despite all its flaws, it's been the most successful encryption we've ever had. So it makes a lot of sense to use what already works on a global scale.
So it sounds like there's a lot of stuff coming in 0.9.
Yeah, it seems like generally this is being pretty well received so far, at least by the comments on the forum.
I'd like to point out that also, I don't know how much meaning to read into this, but 0.9 is a pretty significant version number in itself. The decision to go to versions that start with a 0.9 is really important, because that means we are now heading head on to the 1.0 release of Bitcoin. That's the next step. Essentially, these are the release candidates and betas that will lead to the first official version 1 release of Bitcoin. So it's an important milestone to hit 0.9. The exciting developments in Linux happened between 0.90 and 0.98.
EasyDNS is the Swiss Army knife for your domain names, helping meet their customers' individual needs since 1998. EasyDNS has been an outspoken critic of SOPA and CISPA. EasyDNS was an early supporter of Bitcoin, and now they are proud to sponsor this show. Do business with a company that shares your values. Get a 13% discount when you pay with Bitcoin. Go to bitcoin.easydns.com and be sure to use discount code LTB.